Hey guys, this video is going to talk to you about how do we find the surface area of a cone. Okay, and I've taken my cone here and I've wrapped it kind of like a present so that I can figure out what the surface area is. Because remember, usually for surface area, if we add the different faces together, we can get the total area. Now with a cone, that's a little tricky. I'm going to show you how we get the formula, but I'm really going to recommend you just use the formula once you figure out what it is. Okay, so I've taken this cone and I've taken the bottom, and of course the bottom of a cone is a circle. Okay, that's the radius. Okay, so I made a circle on my paper with my compass that was the same as the bottom. Then this, okay, and again this part's not exactly perfect because I'm human, but it's pretty close. So when I take the lateral area is what this is called, okay, not the base but the rest of it. When I take that off, this actually also came from a circle, but it's not the full circle, so this is just a sector. Okay, so again, when I wrap it around, that's the sector. So when I think about this circle, the radius of this circle came from the slant height of the cone. Okay, so this one down here is just the radius of the cone, but this piece came from the slant height. And for the purposes of what we're doing today, I'm going to call L the slant height. I'm going to call R the radius like we normally do. Okay, some people call this S, some people call this SH. I'm going to use L. That's how I learned it, so that's what sticks in my brain. Okay, so let's see how we actually find the surface area of that cone. So I said we could add together the two faces. Okay, so we have our circle, area of a circle. We've got to do that. And again, what was this? It was the radius of the original cone. Okay, and then we're going to add together that with the area of a sector. Now mine looks like almost half of a circle. It's not quite half. That's just related to the relationship between the height and the radius. It won't always be so half looking. Okay, and again, I'm going to call this, it came from here, it came from my slant height. So you guys can kind of see the actual height going down through the middle, the radius, and the slant height. Okay, so I'm going to call this L for slant height. So we all know how to find the area of this orange part. That's the easy thing, right? Area of a circle is just pi r squared. And the radius for this orange circle is r, so that's the appropriate thing to use. Now the area of a sector is a little bit more complicated. Okay, so remember, area of a sector is I have to find the area of the entire circle and then figure out what portion I'm using. So if I'm talking about the area of the entire yellow circle, okay, remember the yellow circle has a radius of L. So when I say pi r squared, the radius is really L. Okay, but I didn't use the whole circle, I only used this portion. And normally what we've talked about is, well, what's this degree compared to the total number of degrees? We don't know degrees in a cone necessarily. We're not going to worry about finding them because remember, we're putting it together, so degrees doesn't quite make sense for how far we get. Okay, but we do know how this circumference came about. Okay, and that's going to be our part over whole. Okay, and this is what I mean. So when this came from the cone, I have this orange pipe cleaner. It represents the circumference of the base. Okay, it's the circumference of the base of the little triangle. Okay, what does it represent in the yellow triangle? Well, it represents how far around the yellow circle we went to get this portion. And again, I'm human, it's not quite perfect. Okay, but this was circumference of the entire thing, and it became how far around the big circle we have to go. So the part is actually circumference of the little circle, 2 pi r, and the whole is how far around we would go the entire big circle, which would be 2 pi l. So again, this is just the circumference. Okay, now remember, when we're simplifying a fraction in algebra, we're looking for giant ones. So I can see giant ones here, I can see giant ones here. Okay, L squared and L one of those cancel out. So what I have, still pi r squared, that's the easy part. And then I have pi times the radius times the slant height. Now if I write it the way it looks like that. The way I learned the formula is pi r squared plus pi r l. I just flip-flop those, okay? So again, you don't need to know exactly how this all came about, but I wanted you to see it. This is the formula that you need to know, you need to write down, and you need to be able to use, okay? Remember, pi is just our number, approximately 3.14. R, of course, is the radius, and L is the slant height, okay? So let's use that formula and do 2 example problems, okay? This is probably like, Mrs. Miller, why did it take you so long to just get to the example problems in the formula? But it's kind of a cool thing for you to see, okay? And like Mr. Carnes told you guys, I'm a really big fan of every time you're doing a problem like this, write down the formula. So we just figured out that the formula is pi r squared plus pi r l, okay? When you're finding the surface area, you need the slant height, surface area, slant height. That's for Mr. Kleinhans. I know he likes the alliteration. Surface area, slant height. So r, of course, in this situation, 4 is all the way across, so I really only care about that. The radius is 2 centimeters, and I also need to know slant height, and in this case, we're given the slant height, and that's 12 centimeters, okay? So surface area is pi times the radius squared plus pi times the radius times the slant height, okay? If I simplify that part, it's 4 pi, and this is going to be 24 pi. I add those together and I get 28 pi centimeters. Now it's area. Even though it's on a 3-dimensional figure, area is still square centimeters. This is your exact answer, okay? So on a test or a quiz, if we ask you for exact answer, that's what we're looking for. If we want an approximate answer, I'm going to say it's approximately 88 centimeters squared, okay? I see 87.96. That's for sure approximately 88, okay? Our second and final example looks like this. Find the surface area. Again, going back to Mr. Carnes, we're going to make sure that we write our formula first. Surface area is pi r squared plus pi r l. I do not recommend you go back to deriving the formula every single time. Know the formula. Have it written down in your notebook, so when it comes time to take that quiz, you're just opening your notebook up, you're finding the surface area of a cone. Make sure we write that down in our notes so that it's just using this formula, okay? R, in this case, the radius, they gave it to us, it's 10. We didn't have to cut it in half like last time, so 10 meters. And L, okay? So here's my radius, here's my L. But this time, we don't know L. We're not sure what that is, okay? So going back to our model, okay, Mr. Kleinhans did a model like this with a pencil. He said, this is our height, okay? The height goes from the topmost point of your pyramid or cone perpendicular to the base shape, okay? And then your slant height is what goes on the outside. Slant height is helpful for surface area. Height is helpful for volume, okay? And of course, the radius of the cone. So remember, this is just a right triangle, okay? It's obviously a little smaller than that, but we get the idea. So in our right triangle, of course, if we're going to find slant height, we're just doing Pythagorean theorem. So 10 squared plus 25 squared equals the slant height squared. Okay, and we throw that into our calculator, and we get 725 is c squared. So c is the square root of 725, and I'm going to leave that in exact form. If you want to round it right now, you can. Okay. And then I'm going to just go ahead and say, okay, pi times the radius squared. Let's put that here too. Pi times 10 squared plus pi times the radius times the slant height. L is slant height. Okay, so this will be 100 pi. This really doesn't get a whole lot more simplified than that. So plus 10 pi root at 725. That's not a super helpful answer, okay? But we'll get the approximate by just plugging it into our calculator. So 100 pi plus 10 pi square root 725 is approximately 1,160 meters squared. Okay? So you just have to pay attention. Surface area, slant height. If they don't give you the slant height, you have to find it. Okay?